Welcome to Hogwarts Legacy. You're a new student at the famed School of Witchcraft and Wizardry with a unique ability to manipulate powerful ancient magic hidden in the wizarding world. You'll need to uncover what's behind the return of this forgotten magic and who is seeking to harness it to destroy wizard kind, as you may be the one that decides the fate of the entire wizarding world. But before you can study magic and begin to solve these mysteries, you must create the witch or wizard you want to be. When you arrive at Hogwarts, you will be sorted into one of the 4 Hogwarts houses: Gryffindor, Hufflepuff, Ravenclaw, or Slytherin. After you settle into your dormitory, you will meet up with your housemates in the common room. You will then need to attend classes, and you do have some catching up to do as you are starting Hogwarts late as a 5th year. Opportunities for adventure abound in the area surrounding Hogwarts. As you explore, you'll find the world is alive with activity, wonders, and areas of unusual interest. The magical abilities you learn to master through your schoolwork will soon become tested as you unravel a dangerous mystery and discover if the safety of Hogwarts lies in the balance. Master spells. Befriend new allies. Journey across a landscape never seen before. Uncover ancient secrets. As you leave your unique mark on the wizarding world. Here, in Hogwarts Legacy.
Welcome to the Secret of 2022 Autodesk Vision Series. My name is Jose Villeta. I'm the Technical Director for Warner Bros Games Avalanche Studio right here in Salt Lake City, Utah. We've been working on Hogwarts Legacy video game. Hogwarts Legacy is a third-person action-adventure RPG game where you can become the wizard or witch you want to be on this great universe of the wizarding world. So let's get started. Here's an overview of what we're going to be covering today. We're going to cover the asset pipelines and engine tools, ShotGrid automation, the virtual production tools and performance capture workflows, character create and rigging tools, full body animation of bipeds and quadrupeds, and we're going to end it with our cinematic production processes and workflows. First of all, in the asset pipeline engine tools, we're going to give you an overview of what tools we use and applications that we use to create the game. We're going to start from the performance capture all the way to the production tracking. In the performance capture, we can see that we use Vicon state-of-the-art facility, we use Faceware for facial capture, and we use Unreal and Mobile for actually using live previewing on our set. In addition to that, we have the DCC apps. These are the ones that we created the content. Our workhorses here are Maya and MotionBuilder, and we've used other industry standard tools to create our content. In addition to that, we use speech graphics for doing all our procedural generated conversation system in our game. On the automation and the import-export side of things, we leverage TeamCity as our main automation city job system. We will use Perforce for doing all our version control, and we use the FBX and Alembic file formats to come in and out of Unreal Engine. In addition to all these tools that are available publicly, we have our own Avalanche tools as well. We have our own Maya plugins that we have developed, and you're going to hear a little bit about them. We have developed our own automation and scripting tools, and more important, on the editor, we have expanded the Unreal Engine. We use an Unreal Engine 4.7 Chaos version, and we expanded to include our own technologies that are needed to be able to bring this game to life. In addition to this, we do a lot of production tracking where we marry things together between the Autodesk ShotGrid view system and a Jira software for bug tracking and defects. On the ShotGrid automation side of things, we have the following building blocks. First thing, we have a ShotGrid event daemon web service for task updates for ShotGrid 3D assets and shots. Second, we have a Jira bridge that connects the ShotGrid to the Jira bug tracking service, so we can actually have a two-way communication to and from Jira, and that allows us to keep track on task creation, assignments, notes, and status tracking. Finally, we have a Tnc Automation family of jobs that we can do their pull and push into the ShotGrid. We have performance capture assets that are being tracked, mockup takes, uploads, and automated task updates. In addition to that, we have a dailies of automated mission gameplay recordings for all languages and avatar configurations. We track the audio voiceover recording status. We have face capture processing and selection process, and we have a variety of reporting tools. For the ShotGrid event daemon, as you can see, is based out of a variety of steps needed to be able to track ShotGrid and automatically move things along the pipelines. We have done Python scripts that allow us to move things from note taking to task updates, ready to start, and a variety of other events. And then this runs continuously, and as assets are being moved into ShotGrid, we actually track them accordingly. On the Jira Bridge side of things, a key component to be able to track the production. Not only we track the production and track our cinematics on the ShotGrid side, but we also reflect that on our Jira database system. On the Jira system, we have a bridge that connects to and from ShotGrid. It allows you to track notes, it allows you to track assignments, task creation, and we have an event daemon that continuously talk back and forth between ShotGrid and Jira. On the ShotGrid side, we also expanded to have a variety of Python 3 scripts. On these scripts contain things like tracking mocap takes, to tracking face word processing, to tracking voiceover status, shots tracking. So we have a variety of a big tool set of Python scripts that allow us to be able to just maintain a good production along the way. We have a daily system that runs every day continuously, 24/7, 365 a day. First, we have a continuous execution of the game mission automation system. So the game continuously boots itself, captures and runs continuously. We actually capture 4K recordings using the NVIDIA Shadowplay Highlight SDK, and we use those videos to be uploaded to ShotGrid so people can review it. Now, the beauty of this is that you can do a scriptable task system, so you can actually run with different avatar outfits and gender. You can include running on all supported languages, and this will expedite the localization of our game.
Hello there. My name is Brady Campbell. I'm a senior tech here at Avalanche Mocap. Here in our Salt Lake City office, we have a state-of-the-art facility where we capture and implement thousands of animations in our upcoming game Hogwarts Legacy. Follow me and we can take a look at where all the magic happens. We have a full performance capture volume that uses a mixture of Vicon Vantage and Vero cameras, as well as the latest Mark IV facial capture system from Faceware. The morning of each of our shoots, we get our talent suited up and helmets on in order to prepare them to set foot into our volume. We use the production 10-finger marker set in Vicon Shogun in order to capture every tiny nuance of our talent's performance. This includes the motion they produce with their hands and even fingers. We achieve this by using a combination of 14mm markers for body tracking and 9mm markers attached to performance gloves to track the hands and fingers. With the help of the new Mark IV Faceware helmets and gear, we are able to consistently and comfortably capture our talent's great performances without us getting in the way as much. Our head-mounted cameras capture our talent's facial movements at 60 frames per second, synced by timecode to the Vicon body tracking that is happening simultaneously. With the stability the Mark IVs provide and some facial dots, we never miss a frame when it comes to tracking and later retargeting all of our facial performances. Before we get to the stage, we set up the scenes we are working on for the day. After a quick ROM, we have completed the setup of our talent and we're ready to roll. Using MotionBuilder to retarget our mocap data to our characters' rigs, we can then send that data via Unreal Live Link to see how our actors move the characters in engine. This helps us better direct our talents because they can see the environment they're performing in and how they're moving their character at the same time. On the stage, we have a reference camera on a tripod that captures everything our talent does. But we also have a virtual camera that acts as the game camera so that we can capture our talent with a more natural camera feel. Through the VCam, we can craft what the player sees quickly and more efficiently. And the talent have a lot more fun too. Utilizing the real-time tools like MotionBuilder and Unreal, we can see our talent bring our game to life right in front of us, making our production pipeline lean and agile. Directors join us in office or over Zoom to lead the actors in the scenes being captured that day. Because they can see how the actors are performing in real time, they can give more accurate direction based on what's happening in the game. After a long day of shooting, we then move to our post process. Using a TeamCity automated nightly job, all of the day's takes are sent through a processing pass. This is where the mocap marker data is automatically converted to FBX. The takes metadata is uploaded to ShotGrid. Reference and face videos are automatically copied from the AJA decks and uploaded to ShotGrid. Because our reference and face video capture systems are synced with our Vicon body tracking by timecode, all it takes is a few tasks in TeamCity to grab each of the takes and their accompanying assets and put them together on a tracking table in ShotGrid. What's great about this is that the next day after a shoot, everyone on the team can easily go through ShotGrid to check the status of a take as it is being updated at each phase of the post process. Speaking of post-processing, the day after a shoot, our team gets to work on importing the solved and exported Shogun converted data into Maya. After we get the data looking sharp and ready on our characters' rigs, we then send the Maya files to the animation team for final polish and game integration. Automated jobs check for the presence of these files and update ShotGrid status automatically. Through these powerful tools, our magical characters come to life and fill the world that we are building inside of Hogwarts Legacy. And that's it for us at MoCap. We'll pass it on to the rest of the team.
Hi, I'm Dwayne Johnson. I'm the Tech Art Department Head here at Avalanche, Salt Lake City, and I'm going to take you through some of the pipeline we have here for character development.
All right, what you're looking at here is our in-house tool for combining outfit pieces within Unreal. We take the assets that are generated in ZBrush and Maya, we bring them into Unreal to create this large library of pieces that we can mix and match to create different outfits and different characters. Within this, you can see we have quite a variety of different slots that pieces can go in. For this particular demo character, we've got a hat, upper, lower, socks, shoes, scarf, and glasses. If we wanted to add a robe, we could just go to the robe slot and go choose any one of the large number of robes that we've got. And there you go, we've got a robe. You can see that we've already got a material assigned to the scarf. If I wanted to assign or build a material for the robe has already been set up with different alpha regions. So you can see here that we have all these different regions that can be affected by patterns or tinting. For this particular robe section, this robe region, we can go in and we can take and do a knit woven. We can change the tint to something red, and you can see that is the area that is affected by that region. The artist can also go in and they can save off that data. So let's see, right here we got a Hufflepuff, and so these are presets that are saved that the artists have already created, and just allows for easier access to work that's already been done. In a database, we save out the source asset locations, the blend shapes, any rules and scale values that we might have on this. We save all that information out so that we can then process it in Maya. And this also gives us an asset that once we crunch this down, it gives us an asset that we can use in Maya for cinematics and rig that up for the animators as well. So as an example of a character that has already been crunched down, let's look at Professor Ronan right here. You can see that he's just, we've crunched him down to one mesh component, and we've reduced the number of materials to optimize the draw calls on this guy. And so I'm going to show you Maya next. All right, let's show you the Maya part of this workflow. This is our Avalanche Mesh Merge Batch tool we've developed for this project. We take the data that we've saved out from Unreal that's in SQL database form, and then we use that to bring in the pieces, how they attach, any blend values, scale, texture, and shader information. We have several different biped class characters, so we run validations to make sure skeleton hierarchies are correct, positions, rotations are correct. We import each skeletal mesh and run validation on those pieces to make sure everything is clean on those. We bake any body morphs, we bake head morphs, and then we rebase facial blend shapes on those. And then we also bake in any scale on the head, hands, or feet. All right, now that we have a character ready for rigging, we can show you our auto rigger. We do incorporate HIK into our character rigs. We found that it works very well with getting our mocap in and working with that data. First, we do more verifications on the character. We characterize, and then we set up the HIK rig. And there you go. That's pretty much it for our rigging process for bipeds. We have lots of different classes, including humans, elves, goblins, inferi, many other character type classes. We use this for all of our biped characters. We have the same hierarchy on all those, so we can share rigs and share motions across those. And now that we've seen this, let me show you an example of some of our character rigs. Here you can see the biped HIK on a goblin and the human, and then if we take a step back and look at other characters, you can see the hybrid. We've got a hybrid rig of HIK on our centaur. And then for quadrupeds, we try to match the lower half so we can share locomotion on those characters, on those rigs. And then if we take a look back even further, you can see that characters such as the dragon, they are very unique, so they get their own unique rig. And this is just an example of the many creatures and characters that we have in our project. And with that, I want to thank you for your time.
Hello, my name is Matt Dibb. I'm a senior animator here at Avalanche in Salt Lake City, Utah. Join me as we take a behind-the-scenes look at how we leverage proprietary tools and in-stock tools inside of Maya to bring the many animations to life that we have in our game Hogwarts Legacy. So after our motion capture team post-processes and retargets the motion capture data, they send it off to the animation team in a Maya format. And once the animation team has those Maya files, we use a proprietary tool that we call Subscene. And in the Subscene editor, we can quickly import rigs and animations into Maya, and it gives us control of the animations where we can have multiple animations in a single Maya scene. And this is a really powerful tool where it allows the animators to quickly click back and forth between animations. I can quickly connect ending and starting poses if need be. And after I've imported these animations and made changes to them and edited them, and I'm liking where they are, I can quickly right click on this animation file or this subscene and export it to Unreal, and then I can quickly bring the animation up in Unreal and check them in game. Another powerful element of the subscene editor is that each subscene clip or animation clip can have its own animation layers, and these are the same animation layers that are with stock Maya, and I'll show you an example of how we can use that. So for example, I have an animation here where this wizard spins and casts this spell kneeling down. So now if I got this animation and needed to make adjustments to the arm, I can quickly add a normal animation layer and add the arm to that layer, and then I can begin to manipulate and set keys and adjust poses on that animation layer. But the powerful thing about this is that animation layer stays with this subscene clip. It isn't a general thing in the whole Maya scene, but it's each individual subscene has its own layer. And so for example, I can come in here and adjust that arm to maybe shoot up higher if I needed to. And then you can see I can quickly begin to adjust these. And so he's now spinning and shooting up high, or if I need to adjust other parts of his body, I can quickly do that. And those are kept to this Maya subscene. And so then I can also duplicate this subscene and make changes to the duplicate that I've made and keep the original animation. So lots of different ways that I can use the power of these subscenes, but then also in addition to the Maya tools where I'm using animation layers and keeping them with each individual subscene. So another powerful way that we can use these tools inside of Maya. So another powerful way that we use the subscene editor is the way that we use it in connection with Maya's human IK. And so this is a way that we have so many animations in our game and so many different characters. This is a way that that allows us to share animations and adjust them with characters of different sizes and proportions. So for example, here I have a casting animation that is on a male character, a male wizard, but I can bring this I can bring in a female character. And then after I have the two characters in here, I can create a subscene for the female character. This will be an empty subscene with no animation on it. And then I can use the male character to actually drive the female character's animation. so now you see both characters with the same animation, and then I can use HIK to bake that animation from the male character skeleton onto the female character skeleton. And then once it's baked to the skeleton, I bake it back to the control rig. And now each subscene clip has the same animation but on a separate clip. So if I click on one of these characters and pull them to the side, you can see now the male and the female character have the same animation, but it's working perfectly with her proportions as opposed to the male proportions that are a little bit bigger and taller. So this is a very powerful tool that's allowed us to share animations between multiple characters that have varying sizes, to take animations that might work a little bit on one character, but then apply them to a different sized character and adjust those animations so they work for that size. So a very powerful tool that's allowed us to do wonderful things for Hogwarts Legacy. To animate many of our fantastic creatures, we use hand-keyed animation inside of Maya. And so here I have the example of one of our dragons. This is a very complex rig with lots of controls and different ways to manipulate the character. So right now I am in DG mode, or DG of eval mode inside of Maya. And so when I hit play, you can see kind of the lag in the playback speed. It's almost playing it back in slow motion. And as animators, we need to see our animations at full speed. And so one of the tools that we use inside of Maya when using a very complex rig such as this dragon that's very robust and heavy is that we change from DG mode into parallel mode. And now I'll show you the difference. When I hit play in parallel eval, you can see the immediate difference in that it plays back at normal speed that you would see in real time. And so this is another powerful tool that we use as we're animating a lot of these big creatures with very complex rigs that allow us to see their animation played back at normal speed.
Hi, my name is Nathan Hendrickson, and I'm the Cinematic Director and Manager for Hogwarts Legacy. Developing cinematics during a pandemic created a lot of obstacles for us to overcome in a very short amount of time. With actors already cast and outsourcing partners in place, we were ready to go into full production. But in a matter of weeks, all of those plans fell apart. With everyone now stuck at home, including our actors, and most US-based performance capture stages and recording studios closed, we had to find solutions to problems we never expected. We ended up finding Beyond Capture up in Vancouver to help us out, and they were a terrific partner during that crazy time. Now with the stage booked, we worked with Beyond to find local Canadian actors for our body and face needs. Then, once the layouts were locked, our main cast would come back in and ADR to that captured content. Since we had a huge cast of about 50, there was no way we'd find enough actors to fill all the requirements for each role. So we focused on actors capable of inhabiting multiple parts on any given day. It was a logistics nightmare, but with the help of an extremely talented group of actors, we were able to work through the problems and deliver content at a steady pace. For communication with the stage during shoots, we used Zoom. On that Zoom feed, we added quad video with 4 feeds, as you can see here. One of the quad windows showed the real-time playback in MotionBuilder. The other 3 feeds filmed the stage from strategically placed cameras on tripods. Then if we wanted to chat with the actors on stage, we'd use Zoom. If we wanted to chat amongst ourselves, we'd use Slack. Another issue was communication with the actors. The problem was that there were no directional landmarks on stage, so it was difficult to communicate where we wanted people to go. To solve this, we did 3 things. Beyond Capture added cardinal directions on the 4 walls. That made a huge difference out of the gate. The actors also used our set builds on the stage in conjunction with a real-time video stream to see where they needed to go. This is a common practice, but it's especially helpful when directing remotely. Finally, we used our 3 stage cameras for gathering points. If we needed to orient everyone in the same direction, we'd say, "Please face camera 3." We had other ideas like a top-down camera that would also allow us to project digital set onto the ground, but it was a big ask that came much too late in the project, so we let it go.
We had a lot of the same issues on our home stage at Salt Lake City, but the cast was limited to 2 and the stage was much smaller, so communication and blocking was easier to manage. Once our scenes were locked, we created ADR reference files that attached HMC faceplates to the models to help with matching the captured facial animation. From there, the original actors ADR'd to those faceplates, then we polished out the body and faces from there. This process inevitably put a ton of extra burden on our facial and body teams, our pipeline and processes, and our talented main cast who had to ADR hours of content. But it kept us moving forward, and that's what we needed to do to hit our dates. As the data flowed in from the PCAP stage, organization of that content was critical. This was especially true with everyone now working from home. For this part of our pipeline, ShotGrid played a critical role in distributing all of our visual content for creative development, reference, version tracking, and reviews. From here, I'll pass you on to the rest of the team. They'll not only dig into ShotGrid, but also discuss our cinematic pipeline, our layout process in MotionBuilder, and our animation pipe in Maya.
I'm Ethan Walker, the art lead and co-director on cinematics here at Avalanche. I'm going to share a bit about how we approached some challenges unique to our pipeline, some of the ways that we leveraged ShotGrid to merge our runtime and our offline toolsets, and then give you a brief look at how we track one of our scenes from script through to the final picture. So to start out, I just wanted to share what our standard shot test template looks like, show you a few of the customizations we've done to ShotGrid to help tailor it to our needs, and then demo a few workflows we found useful. We chose to set up our pipeline steps in a typical dependency chain. Most of these phases should look familiar. We begin with typical pre-pro phase, which would include everything from the shooting script, storyboards, and any other previs assets. And the tool supports all these different asset types, so things like the script and the boards are all available here in one spot for the team to refer back to. So the next phase is to bring the scene to life on the stage, and then provide that data to the team for layout integration and blocking. But before we get there, we have to review and select from the raw performance capture video reference. So I want to jump over and show you a brief look at our custom setup for performance capture review and the data selecting process. So this is our custom landing page for reviewing and selecting data that we capture on our stage. And you can see we've got fields for each entry with applicable info on that shoot day, general shoot notes, characters present, actors present, props, etc. And if I click through, you can see that the rough cam footage contains not only the standard quad, but also HMCs captured on that day, any real-time previews, etc. And I can quickly scrub and note the desired data range that I want to select for this shoot, then jump back to the landing page, and right here I can enter those ranges for processing. And we get notified when the data is available. We can review it, make notes, or provide feedback. And it's just a nice streamlined approach to managing it all in one place. And now I'd like to show one more way we've utilized ShotGrid to optimize our capture process and approvals. I'll return to the same scene where our hippogriff is in need of rescuing. We shot this in a few different pieces to accommodate some pickup runs and additional shots. Now I've dropped all my selected quads here on ShotGrid, but if I want to go a step further and quickly generate a rough cut of the scene as a whole, I can select all these preview assets, create a playlist, and then open the screening room app. Now once in screening room, I'll pull up that playlist, select all the pieces in order, and now right here in ShotGrid, I can see them play back one by one and identify if I need to do pickups, or if I'm satisfied, I can provide this as a reference for the layout team. Now we've used the same approach with our engine renders to review the game content in context to the layout and animation passes out of Mobu or Maya. Now I'd like to show another small way we bridge our authoring and runtime pipelines. Unlike traditional animation, where typically production's on a per shot basis, we tend to work in a hybrid approach. Some teams working at the scene level, and other teams, like face and lighting, prefer working per shot. Now, we've implemented a number of tools, including the HUD you see here, to help track that per shot content in our Mobu play blasts. This is useful for the teams working in Maya or MotionBuilder, but the data is typically lost when you move into the engine. So the team came up with a way to utilize that metadata from layout and display it here as a UE HUD element in our runtime renders. You can see which shot I'm on, what frame, and even get performance metrics or which build this was rendered from. This helps both production and content teams effectively identify and track content bugs and tasks upstream from the engine. So yeah, that's a quick look at our runtime HUD.
Hi, my name is Travis Phelps. I'm a senior advanced cinematic layout artist on Hogwarts Legacy. Along with layout, I'm also responsible for our tools, workflow, and pipeline in MotionBuilder for our cinematic layout process. So let me take a couple of minutes and show you a few reasons why MotionBuilder is our choice when it comes to cinematic layout.
MotionBuilder's ability to handle anything we throw at it, tons of characters and props, and still run at a high frame rate is one of the biggest reasons we love using it. You can really throw a lot at a scene and you still get playback that is responsive enough to make informed, creative editorial decisions without having to render out individual shots. So we use it for previs all the way to final camera. Another reason we love MotionBuilder is for story mode. We really love using story. In fact, our policy is to put everything in story. And that's because there's very little you can't animate with a story clip. So we say, if you want it animated in your scene, animate it with a clip in story. Some of story's features that are in heavy use while working with performance capture in our layouts are things like clip offsetting, clip blending, clip matching, razoring and trimming clips. And then of course we love the edit timeline's ability to use time discontinuity. When we start standing up the performance capture pass of our scenes, the first feature you reach for is clip offsetting. Getting all the characters from where they are onto their marks in the actual environment is such a crucial step, and using clip offset makes short work of that. Another huge advantage that offsetting gives us is the ability to offset an entire established scene's worth of animation to some new location. And this can happen due to set updates or like a game design change that needs to move the scene somewhere else. You just select every clip and story, move them all at the same time, all relative to each other. It's very, very handy, and it saves us hours, if not days of work. Once all the characters are roughly aligned to the 3D environment, we can start in on shaping our scene out of the PCAP data we have. We razor that data into pieces, we use clip-to-clip matching, we blend clips together, we razor and match and blend, and razor and match and blend over and over, until the layout artist has crafted the scene that they envision. And this can mean all kinds of things, like cutting out unnecessary shoe leather. It could mean taking out or extending or moving the timing of an acting beat within the performance. This can also mean things like extending a walk or changing the direction of the path the PCAP actor actually took to better suit the environment you actually have. And performances can be easily mixed and matched from different captures off the PCAP stage. For instance, a director might request 2 captures from entirely different shoot days be combined together to get the desired performance. Essentially, we invent the performance we need from the parts that we have. Next, we'll talk a little bit about using the time discontinuity feature. Utilizing time discontinuity in story lets us get a little space to breathe on our timeline. I love that it allows you to create a new shot anywhere on your action timeline, but still be able to drop it into the edit of your scene where you need it. And that lets you have control over how you group and organize your timeline. Time discontinuity also makes doing things like iterating on your overall shot sequencing pretty low impact. With very little friction, you can shorten or lengthen a shot, you can swap the order of existing shots, or insert something brand new. You can make a gap in your edit timeline, drop that new shot right into the flow, and see how it plays. And none of the timing or animation on the action timeline is disturbed. Taking advantage of time discontinuity in this way lets you turn around a new version of your scene within minutes. Or you can even do it live on a screen share. You can also leverage 2 shots with overlapping time to accentuate the readability of an action or impact that falls on a cut, because you'll be replaying the last few frames of animation over again after the cut. Time discontinuity is a little mind-bending at first, but once you get used to it, you'll never look back. Now let's talk a little bit about how we set up cameras. We're able to use only a few camera rigs at a time because keeping all the camera animation in a story clip allows you to easily manage where those clips start and end. If you want to set up a camera for a new shot further down your timeline, you can create a fresh empty clip and drop it on any available camera rig. Having a few multi-purpose cameras also allows us to shoot a section of action from multiple angles at the same time and then use the shot track to dial in the editorial between those cameras. It helps us accomplish a grounded style where we establish angles and shots and then can always cut back to that exact camera, rather than recreating a new animation that is similar. You can start to think about your sequences of shots more like footage that you're editing in a nonlinear editing program. Or you can leverage the same multiple angle concepts just to try out alternate angles for your shots. You put in the shot you think works best for the edit, but can keep your alts around just in case. And finally, let's talk a little bit about how we implement our facial capture footage. Being able to add video and audio tracks to Story lets us import and sync our facial capture footage with the accompanying body data via timecode. We can sync exactly with the body or make creative decisions to change the facial performance if it suits the situation. We put a character's specific facial capture footage on a video track in Story and then project that track's footage onto a plane that rides along in front of the character's face. And yeah, it looks a little silly at first, but doing this lets us not only preview the faces with the body data, giving the layout artist much more insight into things like eye lines and other cues that don't necessarily show up in the broader body animation, it also lets us export out only the frames we need to process for facial animation, hopefully saving our facial animation team some time and money. There is a lot more I could say about how we use MotionBuilder and Story in our cinematic pipeline, but that's it for now. Thanks for watching.
Hi, I'm Keith Huggins, a facial animator on Hogwarts Legacy, and I'm going to give you a glimpse into the facial animation pipeline for our game.
Starting off here in Maya, on the left, we have a proprietary tool called the Subscene Editor, which we use to efficiently manage scene assets. A layout artist will create all the necessary elements we need to polish the facial animation, which will appear in this upper panel. It has sections for the camera, the characters, and the environment. Should anything change, like a character's rig or animation or the scene camera, this tool allows us to easily update any of those assets without losing work. Then, when someone has done a round of polish on the animation, we use it to export the necessary files to be brought into Unreal. Here, I've loaded a scene which is a work in progress, and in this wider view you can see the environment, and clicking on this button in this UI, which I'll explain shortly, I can switch to the scene camera. There are two characters in the shot, and in the lower window of the subscene editor, I've imported the nodes for their facial animation. This will bring in the files generated from our motion capture sessions that's been cleaned up using Faceware and attached to our rig. We also use speech graphics to generate facial animation, or we can of course animate a face from scratch. Each character has the same fax-based rig, which allows any facial animation to be applied to any other human character. This is important since our game allows the player to customize their character a great deal, so in each of the cinematics they'll see the character they created interact with the other characters from the story. In this scene, the character on the right is acting as a proxy for that player character, so the animation that will play on his face will be applied to the player's authored character. Selecting the avatar in the upper window, then clicking on the face animation node in the lower window attaches the facial animation to him. Then I'll do the same for the other character named Natty. There are a couple of ways to interact with the controls for the face. To the left of each character's head is a floating UI which moves with them, or this UI to the right can drive their rig. If I assign each character to a slot, like so, selecting that slot will drive their controls. This has more functionality than just selecting face controls, like this button, which allows me to bring in the audio for the shot. On the bottom left are some animation curve editing tools. There are buttons to show and hide different sections of the UI. Here, I'll hide these curve editing tools, and there's a button here to show or hide different types of modifiers on the face. You can show the labels here, and this button unhides these controls which allow you to quickly select certain sections of the face. It can also bring in the face plates from the motion capture session. With a little setup, pressing this button will bring in that footage. I can leave it here, attached to the camera, or I could place it by your head, like so, or I could place it somewhere in the world if I wanted. Now that I have that animation in there, the first step I like to take to polish it to a finished state relies heavily on Studio Library. Here we've set up a wide range of phonemes which, when you select any section of the mouth, can blend toward that pose. Sharing this library gives us consistency between animators and allows me to reference these poses when reviewing shots. For example, I could comment to drive this pose more toward the A pose. We also have a section for moods, so those can be dialed in as well. From there, it's just a matter of polishing the controls to make the character appear to convincingly be speaking their lines and conveying the emotion of the scene. Once it's at a point where an animator wants their work to be reviewed, the subscene editor is used to export that animation, where it's loaded into the file which plays that sequence in Unreal, which will then be rendered, then reviewed by the stakeholders for approval.
Very well. New plan. I get the evidence and you free that hippogriff. Agreed?
So that's a brief glimpse of how we've been doing the facial animation for Hogwarts Legacy. Thanks for your time.
Hey, my name is Kevin Chesnos, and I'm the lead cinematic animator here at Avalanche Software. Super excited to be part of Hogwarts Legacy and to be part of the growing studio here at Avalanche. I'm going to talk about body animation and how we get from what we captured to the final product using this small section here from HST split up. We run up the stairs. Some of the challenges we face is when we're mocapping, it's not necessarily going to be the perfect set. And we're going to do a lot of improving on the day just to get whatever pieces that they might have on the mocap stage to fit what we have in the game. So in this case, all we had was a ramp. Somehow we're going to have to make these feet match the steps. There's a lot of camera tricks and movie magic that go along with that. Our layout team made sure that we were maybe not seeing the exact steps in there. But we still have to make the run look right. And make some matches, so you can kind of see, how we cheated here by running up every other step, which maybe you would do. So for the feet, we're just trying to match to make sure that they stay connected to the ground here as Natty goes up the stairs. So again, I just have a layer that's on top of these. We're seeing them from a distance, so it's going to be hard to tell. We just got to make sure it's connected enough, and maybe even just break into the geometry slightly. For the most part, we're hopefully just cleaning stuff up. In some cases, we have to make the run look like it's going faster or whatever we need to do to sell the idea. And then any cleanup that might happen there as well. You can kind of see the arm looks like it almost bends backwards. When we get to Maya, which is where we do all of our animation, we have several proprietary tools at our disposal. Subscene editor. We do use MG Picker Studio as our third-party rig control system that we set up ourselves, and has a bunch of great shortcuts and tools that we like to use. So in this case, we're making sure that Natty, that her hand is specifically touching the door here. We can see that the hand's not really touching there. I'm going to select Natty's hand. I'm going to make sure it's in IAK. We do use layers a lot. Sometimes it makes it easy just to set a couple keys and hope that we can retain the mocap data. Sometimes we have to completely clear it out and reanimate portions of the body or portions of an entire character. But in this case, I can just go in here and kind of blow some keys away. See if I can get this to match up a little bit closer. So that's just scratching the surface of what it takes to animate cinematics here at Avalanche. I hope you enjoyed watching all of our presentations. And before we go, we wanted to share with you the cinematic that you've been seeing us create. Here it is.
Highwing. Do you know that hippogriff? Very well. New plan. I get the evidence and you free that hippogriff. Agreed? This is our chance. Go!
Blasted! There's gotta be another way to get up to the roof. Somewhere.
Well, I hope you enjoyed the presentation. Thanks for Autodesk for allowing us to share with you the great work of Hogwarts Legacy. We also want to thank Epic Games for all the support we got for the Unreal game engine. And more important, we want to thank everybody that worked on this game, Avalanche software team in Salt Lake City and all the external partners across the world. I hope you have an opportunity to play the game, and thanks for your time.
All right. Hi, everyone. I hope you enjoyed that absolutely fantastic presentation. First of all, a big thank you to all the presenters for being here and sharing their creative process with all of us. I'm really thrilled that we had the opportunity to highlight the talented animators, technical artists, mocap leads, directors, you name it, who dedicated so much time and so much heart in creating this really awesome game. I'm Kelly Ningwani, Marketing Manager here at Autodesk, and I'm really stoked to be moderating this Q&A with the talented team at Warner Bros Games Avalanche. So let's get into the questions. First up, we've got, so obviously there are a lot of moving parts in making this game. What was the biggest learning from collaborating with so many different teams?
So I think the biggest learning that we learned on this project was that access and communication are critical. Access to the builds, access to the code, access to the assets that we create are super important. So we had to find creative ways to share our content through a cloud service for all our performers or a distribution of our builds. In addition to the access, we need communication. So we have people all over the globe, from all the way from the UK to the United States to Australia to Asia. So we had to keep a good communication through Slack and ShotGrid as well.
Great. And what was one of the main reasons or maybe features that pushed you to use ShotGrid in your creative workflow?
Yeah, so as Jose mentioned, we already knew we wanted to use ShotGrid for our communication, and it was a great tool for creative feedback, annotation, task tracking. But the team at Avalanche wanted to leverage it for a lot more than just basic content review. I showed off a bit of that in my presentation with our custom mocap selection and feedback layout. The team also built out a similar portal for our faceplate selecting and processing. And then we also use it as our portal to review our daily renders. So every day the engine will render a batch of scenes, and ShotGrid becomes our repository for all that content. In addition to that, we have a bridge to our bug database so that all of our ShotGrid notes can be tracked and regressed in tandem with the rest of the team. And that's pretty invaluable so that everything doesn't get siloed off into one spot. Yeah, so it went from being a relatively focused content review and feedback tool to something where today it's leveraged by a much larger chunk of the team. You have the mocap group, concept artists, effects artists, designers, and all of the streamlined feedback workflow that we still use in the cinematic group, combined with that backend flexibility, is really what led us to just continue using ShotGrid on Hogwarts.
Great, thanks, Ethan. Now, this next question is kind of a multi-part question. Was it difficult to simultaneously work on set and with remote teams when it came to mocap? And what was the typical turnaround for feedback / edits for the shots that you captured?
Yeah, that was definitely a challenge for the mocap team. We were so used to having our animators come in and direct all of the animations that they need with our talent. We really saw a lot of success from when we moved to our real-time previs setup that we have using Live Link into Unreal. So that way directors at home can see how the talent are actually moving the characters. And then the directors also see how they're moving in the environment. So giving them direction was just that much easier because they both see the same environment. As far as our turnaround for feedback and edits, with all of our automated jobs, the feedback could come in as soon as the week after a shoot, with animators getting their hands on data as soon as a couple days out.
Yeah, I think, overall, we just needed to be, very organized, working remotely. I think Live Link helped a tremendous amount for us to visualize the content, but we needed detailed shot lists. We needed our previs videos, up to date and ready to go. And what's interesting enough, one of the things we did a lot of was we used the actors to sort of help us direct, because sometimes, the fact that they're in the space, they can move people around, specifically the more experienced ones, into the areas that we need them to go, and they start understanding, the things that we want. And so just using them to help us, organize and set up the stage for our each particular scene, and really helped a lot.
I also feel like communication, we've mentioned a couple of times already, but it became so critical to the way that we had to all of a sudden work with being remote and kind of stuck at home with COVID and everything. But an animator is usually using their full body and possibly moving actors around when it comes to the mocap stage. And so now we've got this small little box that we're working in, and we're having to communicate on screens. And so we were quickly shifting the way that we had to see each other and talk to each other. And I think we kind of reinvented a way to communicate, and the actors obviously were super helpful. Everyone was kind of figuring it out at the same time, and it was both a hard experience in some senses, but also something that we got through, and I think we came up with a process that works really well.
Yeah, I think it was that continuity of using the same actors for a year and a half. Like I said, everybody learned each other's shorthand, and it just made a huge difference.
It's pretty safe to say that organization, communication, pretty key to making this game happen. So let's switch gears a little bit. Another question we have here is, did you develop your own proprietary scripts for MotionBuilder import/export workflows?
Yeah, I can take that. Yeah, we absolutely have a full suite of tools in MotionBuilder to be able to intake characters that we make MotionBuilder ready, various props and creatures and the human characters. That will handle everything all the way through export for our shot-by-shot exporting process. And we have some scripts that then do a good job of taking all that data and moving it over into Maya for when we need to do that. We can also move to Unreal from there too. Along with that, we have lots of little widgets and tools to help us move quickly in story, because story is awesome, but it's you can always use a couple of shortcuts. So we have a good set of good story tools, and then the proprietary camera rig and camera rig tool system to sort of work with that quickly. And then I think a little bit of showed of our faceplate hookup widgets and stuff like that. So there's lots of little tools and things to help with our sort of proprietary processes to getting that stuff pushed through and set up correctly, so that we can track it and know what's in scenes and what can go out of a scene and all that stuff. So yeah, I've got lots of stuff.
Awesome. Thanks, Travis. Next question. What can you tell us about the way your in-house tools for software come to be? Does an artist request specifically made tools for a task?
Sorry, I'll take that one. So the tools come to be either through a request for the needs of the project or the needs of an animator or artist. As an example, our subscene editor started out as a need for the project on a previous project for an in-house engine we had. We wanted to be able to organize and export data in our own format. And so that was the needs of the project, and animators needed to use that. So they had requests for making it easier, adding functionality to it. And then that grew. And then we did carry that over into this current project and just built upon that, tried to make it easier to use, made it so that we could organize our scenes a little bit better. And then definitely, if artists or animators have requests for making things easier, we definitely try to accommodate that. Anything we can do to better the pipeline to make things better, so they're not pulling their hair out better.
Yeah, the goal is to keep them, working, keep them focused on being creative and, avoid all those tedious tasks, right?
Yes.
So next question, can a character break mid-animation? More importantly, can a character break mid-animation and then switch to a different animation?
I could take that. Yeah, definitely. That's something that's inherent to all games, and definitely something that happens in our game. Anytime the player has an input on the game, moves the stick or jumps or climbs something or shoots a spell, animations need to be interruptible, or an enemy reacting to getting hit or the player getting hit. And so some of that is handled. We think about that in the way animations start and end, and the way their poses are created. But also we use blends inside of Unreal to be able to blend in and out of animations no matter where, at whatever point in the animation. We also leverage blend spaces inside of Unreal, where you have several different animations that can be blended in and out of depending on the directional input of the player, or a direction that an enemy needs to go. So lots of different ways that we blend in and out of animations at any point in them. So
Awesome. Thanks, Matt. We still have a few more minutes for squeezing a couple more questions. I have one here about, are all facial animation from performance capture or procedurally generated?
It's a mix of both. A lot of it, obviously, with all the performance characters that was captured, on stage with the artists. Unfortunately, because of COVID, it wasn't necessarily the case that the motion capture artist was also the voice actor. So we had to capture a lot of that after the fact. So it's a lot of facial capture using faceware to then put it onto our rig. But then also we leverage speech graphics quite a bit to do, bronze and silver level cinematics, but also translate into 14 different languages. So we can do our polish on the upper face, and then speech graphics will take care of doing that. So a person playing in France or Japan will see their language, their character speaking their language using lip sync.
Sweet. I think I can squeeze in one last question, because I think this might be a fairly quick one. I see you are using custom Maya build, correct?
Correct. We work with Autodesk on a DSP Enterprise program, where we not only use the stock Unreal Maya that you get, or MotionBuilder, but we work with the Autodesk team to improve, fix bugs, and expand the functionality as needed. So we have what we call a custom PFix build for both MotionBuilder and Maya.
Awesome. Well, I guess that's a wrap. I want to thank you all again, Jose, Dwayne, Kevin, Brady, Keith, Travis, Nathan, Matt, Ethan, for all of you for being here, for being part of our Vision series. And I want to thank all of you watching from home, maybe from your office. Thanks, everyone.
Thank you.